Mercury is the least explored of the four rocky planets of the inner solar system. It took until 2011 for the first spacecraft, NASA's probe Messenger, to enter into orbit around the planet. In comparison, Jupiter, roughly 5 times more distant from Earth, welcomed its first orbiter already in the 1990s. Mercury is also notoriously difficult to observe from Earth. Because Mercury is so close to the Sun, it is hard to directly observe from Earth except during a dawn or twilight, when the Sun's brightness doesn't outshine little Mercury. However, 13 times each century, observers on Earth can watch Mercury pass across the face of the Sun, an event called a transit. This rare transit falls within several days of May 8 and November 10. Previous transits occurred May 7, 2003, November 8, 2006, May 9, 2016, and November 11, 2019. The first spacecraft to visit Mercury was NASA's Mariner 10, which imaged about 45% of the surface. NASA's Messenger spacecraft flew by Mercury 3 times and orbited the planet for 4 years before crashing on its surface at the end of its mission. The European Space Agency and JAXA launched a joint mission to Mercury in 2018. The mission, called BepiColombo, is made up of 2 spacecraft. ESA built the main spacecraft, the Mercury Planetary Orbiter, and the JAXA supplied the Mercury Magnetospheric Orbiter. BepiColombo captured its first views of Mercury during a flyby on October 1, 2021. A total of 9 flybys are planned to help steer the spacecraft into orbit in the late 2025. It will begin its primary science mission in early 2026. Out of the 5 planets known since ancient times as the Wandering Stars, Mercury is one least explored. Unlike Venus, Mars, Jupiter, and Saturn, Mercury is notoriously difficult to observe from Earth. Although the planet can be observed with telescopes during daytime, astronomers need to take extra precautions since the intense sunlight and the constant proximity of the Sun could damage the optics. Larger telescopes are frequently not allowed to look in the direction of the Sun at all because of the damage they could sustain. Interestingly, one of the most powerful astronomical observatories to date, the legendary NASA ESA Hubble Space Telescope, never imaged Mercury orbiting Earth at the altitude of about 550 kilometers. Hubble observed some very distant celestial objects, such as the blue supergiant star named Icarus, some 14 billion light-years away. It has, however, never looked at Mercury out of concerns about damaging its sensitive optics. Although NASA's Mariner 10 flew past Mercury 3 times in the early 1970s, while orbiting the Sun, it took until 2011 for the first mission ever, NASA's Messenger, to enter into orbit directly around Mercury. In comparison, Mars received its first orbiter in 1971 and Venus in 1975. Jupiter, as it closest, nearly 630 million kilometers away from Earth, compared to Mercury's average 77 million kilometers, welcomed its first orbiter in 1995. Even the more distant Saturn preceded Mercury with a Cassini mission, a joint project by NASA, ESA, and the Italian Space Agency, by 7 years. Why is Mercury so little studied? After the 3 brief Mariner 10 flybys in 1973 and 1974, nothing happened in the exploration of the innermost of the planet of the solar system for nearly 4 decades. Surprisingly, despite being much closer to Earth than Jupiter and Saturn, Mercury is actually difficult to reach. According to some estimates, it would take less energy to get to the dwarf planet, Pluto, than it takes to get to Mercury. The reason for this is Mercury's closeness to the Sun. A spacecraft aiming to not fly past Mercury while in orbit around the Sun, but to enter into orbit around the planet directly, has to constantly brake against gravitational pull of the star. There are two ways how to accomplish this braking, says Johannes Beckhoff, ESA project scientist for the BepiColombo mission. You either need a huge spacecraft that carries a lot of fuel, or you can use the gravity of other planets to slow you down along the way. To reach Mercury, you need to perform multiple such planetary flybys, and so the journey takes a long time. It takes less than 2 years to ESA Sun Explorer Solar Orbiter to reach its target orbit around the Sun, which is even closer to our parent star, Mercury. BepiColombo surprisingly needs 7 years to put itself into right position to place its two orbiters, ESA's Mercury Planetary Orbiter and Mercury Magnetospheric Orbiter of the Japan Aerospace Exploration Agency, into the right orbits around Mercury. To get there, the spacecraft has to perform an overall 9 gravity assist maneuvers, or flybys, that will help it brake and adjust its trajectory. The ambitious plans that European scientists have for BepiColombo stretch the engineering teams of ESA and its collaborators to their limits. Daniel Stramaccioni, ESA's BepiColombo system engineer, compared the situation that BepiColombo will face to sticking working laptop inside a hot pizza oven. Not only sunlight around Mercury about 10 times more intense than near Earth, the planet's scorched surface also radiates heat back to space. As a result, MPO will have to endure temperatures up to 450 degrees Celsius, hot enough to melt lead. Materials used in standard space mission are not capable of withstanding such high temperatures. For example, solar rays start falling apart at 40 degrees. The engineers therefore had to find completely new materials for the job. A carbon fiber reinforced polymer enabled stretching the workable temperature of the solar panels to over 200 degrees Celsius, but the arrays still need to be tilted up to 70 degrees to reduce sun exposures. Not only will BepiColombo face extreme heat, on the night side of Mercury, temperatures can also drop as to 180 degrees Celsius, putting the materials under further stress. During the development, the ESA had to make changes to its testing facilities and the European Space Research and Technology Center in the Netherlands to accommodate the challenging mission.